We'll look at a couple examples from 6.1 from the homework. Both of them are designed to illustrate ideas that we didn't get to in the previous video. So let's start with number 16. So the instructions for 5 through 26 ask you to do quite a bit aside from just finding the area. But let's take a look at what we've got with 16. We've got a parabola y equals 8 minus x squared. So that's this downward opening parabola. And just regular old y equals x squared, which is this one. And they ask you to find the area between -3 and 3, which is not where the two curves intersect. They intersect at -2 and 2. So we're going a little bit beyond that. They're asking you to actually find the total area here, both the kind of red shaded area and the purplish shaded area. Our basic idea for finding area is to say, let's do the upper function, whatever that is, minus the lower function. So minus the lower. And if those change in the middle of the problem, we'll need to do separate integrals. So we're actually going to have to do two pieces here. We're going to have to do one part that goes from -2 to 2, where the downward facing parabola is the upper one. Right? So that portion will be 8 minus x squared, the upper, minus x squared, the lower, dx. Then we'll also have to do a separate integral from 2 to 3, where the upper function is x squared and the lower function is 8 minus x squared. Technically, we'd have to do that from -3 to -2 as well. But notice that these curves are exactly symmetric, and we're finding areas, so I'm just going to double that rather than doing two separate integrals. Okay, so let's talk about their extra bits of information. So we did sketch the region, we did that. I am going to decide to integrate with respect to x. Notice my two integrals here both have dx. Draw a typical approximating rectangle. And what they mean by that is going all the way back to the Riemann sum and saying, hey, the rectangle now wouldn't go all the way down to the x-axis. It would go down to where it hits the other curve. So I'm going to say there's one little approximating rectangle. They want you to label its height and its width. So its width is still a little bit, is a dx, a little change in x. And its height, at least for this one in the red area, is given by the upper curve minus the lower curve. So its height is 8 minus x squared. And I'll just crunch that down algebraically. Say it's 8 minus 2x squared. Basically, they're just walking you through setting up the integral that I already have written over here. And really, once we have those two set up, I think the actual doing of the integration is not going to be too bad. And I'm not sure I'll even finish it because you know how to do this part, but let's say we would have, if we integrated that, it'd be 8x. And I am going to go ahead and crunch these down to minus 2x squared. So when I integrate that, that'll be minus 2/3 x cubed. And we're evaluating that from -2 to 2. And you can plug those in and crunch them. I think I won't even finish from there. But you'll get the number out of that one. And this one, we are integrating negative. Well, here, let me rewrite this underneath here. This will be 2x squared minus 8. So that'll be 2/3 x cubed minus 8x. Notice just the opposite of what we got before, which makes sense since we switched the subtraction order. And we'll do that from 2 to 3. And you can finish that number as well, but then it will just be that one plus that one. On this last one, don't forget that we're still multiplying it by 2 out here. To say we've got this one and we've got that one. Okay, so you can finish crunching that out, and that will give you the final answer for number 16. So let's take a look at one more problem. So let's get rid of that one, and let's look at this one. This is number 3. And notice for number 3, it's maybe a little bit hard to tell what the actual functions are, but the two functions are actually both written in terms of x. So they're sort of these sideways functions from what we normally expect to see. You've got x equals y squared minus 2, which is a parabola. It's just a sideways parabola. And x equals e to the y, which is an exponential function, but again, also kind of sideways from what we'd expect to see. And they've given us limits of integration in terms of y as well. Y equals -1 to y equals 1. So we set up this integral sideways rather than being upper minus lower, which is what we're used to thinking of. It's still really the upper or the bigger function, but when you're going sideways, the bigger one is the one that's on the right, and the smaller one is the one that's on the left. So we're still following that same basic idea of bigger minus smaller. But let's see if we can set this integral up. We are going to do the rightmost bigger function, which is e to the y, and then minus the smaller or leftmost function, which will be y squared minus 2. When you draw your typical approximating rectangle through here, notice the short side is y, or is vertical, so it's a dy, which is good because all our variables are y's. Our limits are y's. We go from y equals -1 to y equals +1. And we have that all set up, and maybe I'll simplify just a little bit, and again, I probably won't finish it all the way out. This is e to the y minus y squared plus 2. Integrating with respect to y, so when you do the actual integration, that becomes e to the y minus 1/3 y cubed plus 2y, integrated from -1 to 1, and you plug 1 in and you plug -1 in. Let's see, we've got a couple minutes, so let's do this. Go ahead and plug 1 in. So that'd be e to the 1 minus 1/3 1 cubed plus 2. So that's plugging in 1, and then minus plugging in -1 will be e to the -1, and -1 cubed is -1, so we'll get plus 1/3 and minus 2. And then don't forget, we're still distributing this minus sign. So our final answer is going to look like e minus 1/3 plus 2 minus e to the -1 minus 1/3 plus 2. So let's see if we can crunch this down a little bit more. E minus e to the -1, or maybe 1 over e if you want to do that. Then minus 2/3 and plus 4. And 4 is 12/3 minus 2/3, so I guess you could really turn this into 10/3, but that's about as far as you can take it. Okay, there's only a couple problems in the homework that give you functions defined in terms of x. I think 3 is one, and I think maybe number 17 is the only other one. But they give you a couple just to keep you on your toes.